I thought that I would give you a hand with aluminum acetate here because it's a horse of a different color and a little bit difficult. So let's go ahead and start by doing exactly what we did with all the other compounds. Let's split it up. We're going to figure out the individual oxidation states. Now, aluminum, let's go ahead this time and start with aluminum because just like group 1 and group 2 metals, we know that aluminum has a constant charge in compounds, which is +3. So we know it's +3. Oxygen is the most electronegative, so we're going to give it a -2. Now there are 3 times 2, that's 6 oxygens, times a -2, which is -12 total charge. Now, keep in mind, the oxidation state for each individual oxygen is a -2, not -12. This is just accounting, okay? Now, hydrogen we know is going to be +1, okay? It just is. And there are 3 times 3, that's 9 of them. 9 times a +1 is +9. And I'm just going to plop that down here. Now, here's the deal. This is a compound, so all the oxidation all the oxidation numbers down here in the accounting, they have to add up to 0. I've got 3 plus 9 plus, which is 12 plus a -12 is equal to 0. So that would make the oxidation state of carbon actually 0 oxidation state. And on average, it is, but that's not the whole story. So if I draw the Lewis structure, which is what this is, you're going to learn how to do this later on in the semester, I would have something that looks vaguely like this for acetate. I'm just going to exclude the aluminum for simplicity's sake, because right now we want to know what's going on with carbon. So hydrogens, they all get their +1, +1, +1 for that guy. That's a total of +3 for the hydrogens. The oxygens get their charge of -2. Between the two of them, that's a total of, that is a -4. Okay, so that would satisfy that requirement. And again, you'd have to say the carbons are 0 oxidation state. But here's the deal. These two oxygens are very electronegative. They are taking the electron density away from this carbon, oxidizing this carbon, because the electrons are drawn away by both of these oxygens, which makes this carbon a +3. Now, this carbon over here, it is hooked up to 3 very low electronegativity hydrogens, so it's actually a -3 because it's more electronegative than the 3 hydrogens it's hooked up to. Well, -3 and +3 add up to 0. So on average, if you look at the carbons collectively, they are 0. But the truth is you've got a -3 for the carbon number 1, and you've got a +3 for carbon number 2. So let's go ahead and finish it out. For aluminum, that would be +3. And for acetate, C2H3O2, that would be a -1. That's the ion with its charge. And then the oxidation number, if I call this carbon 1, we would say it's -3. It's completely reduced because it's hooked up to 3 low electronegative hydrogens. And then carbon 2, because it's hooked up with 2 very electronegative oxygen, is a +3. On average, the oxidation state of both carbons is 0. For hydrogen, that's going to be +1. That's your hydrogen. And then for oxygen, that's a -2, as usual for oxygen in compounds. Okay, we're just going to let that stand by itself.